I am Anil Kumar sharing with you questions from my subscriber Brian. Brian, thanks a lot for posting these excellent questions. Now, with the help of all the subscribers and viewers, my focus has changed to not creating problems but finding creative solutions. So we have 4 questions here. The first one is, prove that cos 3 theta equals to 2 cos theta times cos square theta minus sin square theta minus half. Question number 2. Show that half of sin 6 theta minus sin 2 theta equals to 2 cos square 2 theta minus 1 times sin 2 theta. Question number 3. Solve sin 6 theta minus sin 2 theta equals to 0, where theta is between 0 to 90 degrees. You can apply this formula here. Question number 4. Find all possible values of cos theta, not theta, right? Find all possible values of cos theta for 2 cot square theta plus cos theta equals to 0. You can always pause the video, answer these questions, and then look into my suggestions. Now we are actually working with compound angle. Some of my subscribers may not know about it. So I'll write down a few formulas here and derive the formulas which are required. So one formula which we are going to use is cos A plus B, which is cos A cos B minus sin A sin B. Sin A sin B, right? So if I make this as cos, let me write here cos A minus B also, then the only thing which changes is that sign. So we get cos A cos B plus sin A sin B, right? Now this is one set of formula. Then we also use sine formula, which is sin A plus B, which is sin A cos B plus cos A sin B. With the negative value, I could write this as sin A minus B is sin A cos B minus cos A sin B, right? So these are the 2 formulas which will be applied. So we have double angle formulas also. So let me take it to the next page, and there we'll derive formulas for cos 2 theta, then we'll get to cos 3 theta. Is it okay? So we'll derive formulas for cos 2 theta and also for sin 2 theta. So that's what we'll do first. Those of you who know this, they can skip the next couple of minutes, right? So, okay, let's take up a new page here, and here we'll derive formula for cos 2 theta. So as I was saying, cos A plus B can be written as cos A cos B minus sin A sin B, right? So that is cos A plus B. Now if I replace B with A, then what happens? If I put B equals to A, then I could write this as cos A plus A, right? So we get cos A minus sin A sin A. That gives you cos of 2A, right? And this is cos square A minus sin square A. So that is one formula which can be applied. We could also write sin square A as 1 minus cos square A. So I could also rewrite this as cos square A minus 1 minus cos square A, right? Since we know that sin square A plus cos square A is 1, and when you open this bracket, we get cos 2A equals to so this minus minus becomes positive, so we get 2 cos square A positive 1. So there is third formula which can be derived. However, we are going to use these 2 in our solution of the given questions. This is one double angle formula, and that's the other form of the same formula. Is it okay? Now if I work with sine, I could say sine A plus B is sin A cos B plus cos A sin B. If I write B equals to A, I can say sin A plus A equals to sin A cos A plus cos A sin A. And that gives me 2 sin A cos A for sin 2A, right? So double angle formula. Is it okay? So that is the double angle formula which we are going to use for sine. So now let's move on, and we'll take up the first question, which is cos 3 theta. So we have to prove this particular formula for cos 3 theta. We could write this as cos 3 theta equals to cos of 2 theta plus theta, correct? Now we are looking for cos square theta here. So first I'll use the compound angle formula, which we wrote as cos A plus B equals to cos A cos B minus sin A sin B, correct? So I'm going to use this formula here, and I'll write this as cos 2 theta times cos theta minus sin 2 theta sin theta, correct? Now for cos 2 theta, we just derived another formula, which is 2 cos square theta minus 1, right? So we're using that formula now. So instead of cos 2 theta, I'm going to use 2 cos square theta minus 1 times cos theta. And for sin 2 theta, we'll use 2 sin theta cos theta. We already have sin theta there. Okay, so from a previous derivation, we got these formulas, correct? Now, at this stage, what we need to find is 2 cos theta we need to factor out. So we are looking for a Q factor here. So let's open this bracket, okay? Or we can just factor out 2 and cos theta. See, we are looking at this term, 2 cos theta, 2 cos theta, right? So let's factor this 2 cos theta out. And what do we get? So we factor this 2 and that cos theta, okay? So when I factor 2, this becomes half. I kind of skipped one step. Anyway, so, or what should I do? Okay, so let me write like this. I'm just writing cos theta here for now, right? Factoring out 2, so I get cos theta minus half here. Let me do it in 2 steps, right? And I'm not factoring from these 2, so I'm just writing this as 2 cos theta sine square theta. Okay, so I'm not skipping this step. Okay, so that is what you get, right? Now you can see 2 cos theta is common, so we get 2 cos theta factored, and here we get, I'm sorry, this is cos square. We just kept this here, cos square. So here we have cos square theta minus half, and from here we get minus 2, 2 is factored out, so sine square theta, correct? So what we did was we factored this 2 cos theta. So we're left with all the term inside minus that. Now it's just a question of rearranging. So what we get here is the right side, which is cos theta 2 times, and we have cos square theta minus sine square theta minus half. Perfect. So that is how you're going to solve question number 1. Now let's move on to the next question. Question number 2. Show that half of sine 6 theta minus sine 2 theta equals to 2 times cos square 2 theta minus 1 times sine 2 theta. Now some of you who know the formula to convert difference into product can apply that formula and solve this question. However, I'll actually derive and then work it out. So let's begin with the left side, which is given to us as half of sine 6 theta minus sine 2 theta. So the trick here is to write 6 theta and 2 theta as sum and difference of two numbers, which in this case clearly is 4 theta and 2 theta, right? So I could write 6 as sine of 4 theta plus 2 theta, right? And I could write, minus 2 theta as 4 theta minus 2 theta, correct? So that is how we can write. Now using sine A plus B formula will expand. So we get half of, expanding the first part, we get sine of 4 theta cos 2 theta plus cos 4 theta sine 2 theta, right? Minus, for the next one, we get sine of 4 theta cos 2 theta. Since this is minus, it will be negative. Cos of 4 theta sine of 2 theta, right? Now from here, you will see that the first term gets cancelled. The other term, minus and minus, makes it plus. So what we get here is half of 2 times cos 4 theta sine 2 theta, right? Now half and 2 cancel, so you get cos of 4 theta sine 2 theta. Now we have 4 theta here, sine 2 theta is already there with us. We can apply the double angle formula here to find what and write this as the given formula. Is it okay? So we are now applying the formula, which is cos 2a is equals to 2 cos square a minus 1. So in our case, a is 2 theta, right? So in our case, a is 2 theta. And we'll rewrite cos 4 theta as 2 times cos square 2 theta minus 1, and we already have sine 2 theta. So that becomes the right side. Is it okay? So we have shown how this side is equal to that. Now let's get back to question number 3. Now in question number 3, it is kind of related with this, since we are trying to solve the equation sine 6 theta minus sine 2 theta equals to 0, right? So from here, we can always write, let me rewrite this. From here, we can write what is sine 6 theta minus sine 2 theta equals to. So let me write this. We get sine 6 theta minus sine 2 theta equals to 2 times, that gets multiplied, right? 2 times 2 cos square 2 theta minus 1 times sine 2 theta. Perfect. So that is what we get. So I'm going to use this particular expression in the solution of question number 3. That is how they are related. So we need to solve the equation sine 6 theta minus sine 2 theta equals to 0. I can factor this, and I could write this as, so we have, let me rewrite, sine 6 theta minus sine 2 theta equals to 0. Now we learned how to factor this. It could be written as 2 times 2 cos square 2 theta minus 1 times sine 2 theta equals to 0. Do you see that? So that is how you would actually rewrite this. And that should help you to get the solution within 0 to 90 degrees. Does make sense to you, right? So now it really means that this could be true if first factor is 0 or the second factor is 0. Is that okay? So or the second factor is 0. So we are looking for not two solutions here. One is for 2 cos square 2 theta minus 1 equals to 0, or sine 2 theta equals to 0. And we're working in the domain where theta is between 0 to 90 degrees. Now look here. If theta is between 0 to 90 degrees, then 2 theta is between what? I have to multiply this by 2. So I get it 2 theta is, 2 theta is between 0 to 180 degrees, right? So if you multiply by 2, you get the domain for 2 theta. So let's solve them one by one. So the first one could be written as 2 cos square 2 theta equals to 1, cos square 2 theta equals to half, cos 2 theta equals to 1 over square root 2, and plus and minus, because it was square. So whenever you do, you have to do plus and minus. So that really means we are looking for 4 solutions, 1 in each quadrant. But our domain is from 0 to 180 degrees for 2 theta. So we are only looking for 2 solutions here, which are in this region. So these 2, you get the idea, right? So we could say, and 1 over square root 2 means we are looking for 45 degrees as the acute angle. So 2 theta is either equals to 45 degrees or 180 minus 45, correct? Or 180 minus 45. So those are the 2 solutions. So we could do 180 minus 45. So that is 135 degrees. Is that clear? So that is the value of 2 theta. So what is theta equals to? Half of these. So half of 45 degrees and half of 135 degrees. So these are the values for theta, correct? Now let's solve for sine 2 theta. Sine 2 theta can be written as 2 sine theta cos theta, okay, equals to 0. So that means we're looking for solutions as sine theta equals to 0 or cos theta equals to 0. So these are also solutions. Now to find sine and cosine solutions, I always prefer to just sketch and then pick the values from there. So we can sketch both the functions. So what we get here, sine theta is kind of like this, cos theta is kind of like this. Now we're looking in the domain 0 to 90 degrees for theta. So that means only in this domain, right? So only in this domain. So we have 2 solutions for theta. One is for sine theta equals to 0, we have that solution, that means 0 degrees. And for cos theta equals to 0, we get 90 degrees. Theta equals to 90 degrees. And so we have all our solutions here. So the answers are 0 degrees, 45 divided by 2. Let me write 45 degrees divided by 2. 90 degrees and 135 degrees divided by 2, right? So these are 4 solutions for our question. So I hope the steps are absolutely clear, and that is how it can be done. So let's move on to the last question now. Now here's question number 4. We need to find all possible values of cos theta for 2 cot square theta plus cos theta equals to 0. So the equation given to us is 2 cot square theta plus cos theta equals to 0. We need to find cos theta. So let's rewrite cot as ratio of cos and sine. So we get cos square theta over sine square theta plus cos theta equals to 0. Now from here we can take cos theta common. So we get one factor as cos theta. So we get 2 cos theta over sine square theta plus 1 equals to 0. Now we could write this as cos theta, take sine square theta as a common factor. So we get 2 cos theta plus sine square theta equals to 0. Now we could write sine square theta as 1 minus cos square theta, right? So we'll rewrite this as cos theta times 2 cos theta plus 1 minus cos square theta divided by sine square theta equals to 0. That gives you a quadratic equation in cosine. So we get cos theta times, let's take minus also outside, right? So let's take minus outside. So we get cos square theta minus 2 cos theta minus 1 over sine square theta equals to 0, right? So we have a factored form and a quadratic equation. Now we need to find the values for cos theta, right? Not the angle theta, but cosine theta. So when this term on the left side is 0, we get one answer, which is cos theta equals to 0. That is one possible solution, correct? For the next solution, we need to equate the numerator to be 0, which is cos square theta minus 2 cos theta minus 1 equal to 0. We can use quadratic formula. This will not be factored otherwise. So cos theta equals to minus b, which is 2, plus minus b square, which is 4, minus 4ac, minus minus becomes positive, plus 4. So I'm just straight away using the quadratic formula divided by 2a. So that gives you 2 plus minus square root of 8 over 2, which is 2 plus minus. 8 is 4 times 2, so it could be written as 2 square root 2 over 2. And dividing by 2, we get 1 plus minus square root 2. So the possible solutions are, let me write down our answer now, is that cos theta is equal to either 0 or 1 plus minus square root 2. So we get 3 solutions for the given question, right? Here we have applied the quadratic formula. I hope you remember. The quadratic formula is x equals to minus b plus minus square root b square minus 4ac divided by 2a, right? So that's the formula being applied here. So as you can see, we can actually solve cos theta by factoring. So that's kind of important. Let me thank Brian for sending all these questions rather, and giving me an opportunity to provide you with a solution. I hope you understand and appreciate it. Feel free to write your comments, your views, and if you like and subscribe my videos, that'd be great. Thank you and all the best.